Welcome to myprojectbazaar.com. Our project title is PROVEST, Provenance-based trust model for delay-tolerant networks. Abstract. Delay-tolerant networks are often encountered in military network environments where end-to-end connectivity is not guaranteed due to frequent disconnection or delay. This work proposes a provenance-based trust framework, namely PROVEST, that aims to achieve accurate peer-to-peer trust assessment and maximize the delivery of correct messages received by destination nodes while minimizing message delay and communication cost under resource-constrained network environments. Provenance refers to the history of ownership of a value, object, or information. We leverages the interdependency between trustworthiness of information source and destination information itself in PROVEST. PROVEST takes a data-driven approach to reduce the resource consumption in the presence of selfish or malicious nodes, while estimating a node's trust dynamically in response to change in the environmental and known conditions. This work adopts a model-based method to evaluate the performance of PROVEST, that is, trust accuracy and routing performance using stochastic Petri nets. We conduct a comparative performance analysis of PROVEST against existing trust-based and non-trust-based DTN routing protocols to analyze the benefits of PROVEST. Let us see the flow of our project. First, network formation is done. Then afterwards, the network formation is done. We have to evaluate the random mobility model in our delay-tolerant network. From that delay-tolerant network, attacker interruption is done. We have to evaluate the black hole attacks in our project. For identifying the attacker nodes, we implement PROVEST, that is provenance-based trust model implementation. If it is validated, we have to implement the three-phase identification, that is trust dimensions, trust aggregation, and trust computation. Trust dimension or calculate the data integrity, data availability, and competence. For that trust aggregation, we have to evaluate the provenance informations, and the trust computation, we have to evaluate our evidence of our provenance, that is previous routing table informations are stored in this trust computation. Afterwards, a successful data transmission is done using transmission phase, and we have to evaluate our project using throughput, delay, and packet delivery ratio. Let us see the output of our project. First, open the VMware workstation. In that, we have to open this terminal window. In this terminal window, go to the folder, product folder, and type ns main.tcl for running our main file. This printing is nothing but our provenance computation and trust computation, that is the provenance value is displayed here, and our security defilement function is displayed here. So security, data integrity is ensured. It is calculated in time dimensionality, that is dimension, data integrity, data availability, and competence. This is our output file, that is a network animator file. When we start this play forward button, it will works. We have to increase the speed, and first source and destination node is formed. Afterwards, it will start the random mobility model. So it's randomly moved anywhere. Afterwards, the attacker node, that is in our project we have implemented the black hole attack. So now attacker is formed, that attacker nodes are drop the packets. So 8 at time 8.3 it dropped 230 bytes of packets. We have to identify this by using our trust implementation. Now the node 6 transmit the information to the node 3, either 3 or 2. So it transmit the information to node 2. It is act as a black hole attack, so it drop the packets. Afterwards, it's identify the trust root, that is node 4. Node 4 get the information from the source node 8 and it transmit the packets to the neighbor node 3. The neighbor node 3 transmit the information to neighbor node 0 and it transmit the information to the neighbor node, that is destination node 13. The successful packet transmission is done. This neighbor node information, that is node of 4, 3, 0 and 13. This is a trust path for calculating our performance evaluation type. The performance evaluation is done by using graphs. So in our NS2 we have two graphs, that is X graph and a GNU plot. We use X graph for our calculation. So type X graph space delay.xg. This is for our delay computation graph. We achieve less delay. This is our delay computation graph. For throughput calculation, thr.xg. So this is our throughput. So we have to increase our throughput, that is the number of successive packets sent at a time is increased.